Are you tired of constantly forgetting to water your plant manually? Well, we have a solution for you. Here is our plant watering system. Our problem is, how can I keep my plant watered regularly without needing to check if the soil is too dry?
The electric plant watering system is best suited for people that have a busy lifestyle but would also like to keep their plants thriving.
Here is where I defined all the integers. In the setup is where I established the outputs and the inputs, as well as connected it to the serial monitor. In the loop is where the interesting stuff for the project happens. There's an if statement for when the moisture percentage is below 84. This also converts the number that the moisture sensor is reading to a percentage. And once that process happens, it's gonna tilt the servo 50 degrees and it's gonna turn the LED on. After this is done, the moisture sensor will probably pick up a higher percentage than 84. And once that happens, I'll be able to push a button with this if statement, which will turn the servo back to its original position. And it'll also turn the LED pin off.
As for the main features and functions, first we have a soil moisture sensor, which is placed into the soil. It will then detect the percentage that the soil needs to be at. If it's lower than a certain percentage, what will happen is that the servo will turn, and this servo is connected to a stand which holds the water cup. The water cup will then turn 40 degrees into the soil until it reaches that percentage. After this happens, the LED on this wiring will turn on and let the user know that water will need to be refilled into this cup. After the user refills the water into the cup, they will press this button, which will then reset the entire thing.
To create the cup in SOLIDWORKS, we first extruded a cube and made a cut so that the walls were only 1 millimeter thick. We made an indent on the side of the cup to fit the servo snugly and keep it from falling out. To create the spout, we made a swept extrusion and cut on one of the sides of the cup. The spout was needed so that we could release any water that would be stuck at the bottom of the cup. After the spout was made, a lid was created by extruding a flat surface with 4 pegs attached. We also added 4 round 1 millimeter cuts atop the cup to firmly secure the lid. When the cup was printed, it was printed in the A orientation with support settings set to everything, with more supports painted on inside the spout to ensure that it was well supported. The cup was printed using generic PLA at 15% infill and a printer setting of 0.3 millimeter draft. Originally, the cup wasn't waterproofed. To make it waterproof and functional, we had to anneal it by heating the 3D print with a heat gun set to high until the print became pliable. And then after, we allowed it to slowly cool. This process allowed for the gaps to be tightened and the filament to be ultimately waterproof.
Thank you guys so much for watching today. Does anybody have any questions?